Hello, and welcome to Lesson 1.5, Expressions Involving Absolute Value. Our objective for today's lesson is that I can evaluate absolute value expressions. Our vocabulary is just absolute value. What is it? The distance of a number from zero on a number line. That is our definition of absolute value. So, in a little bit bigger context, for any real number x, if x is positive or zero, then the absolute value of that number is x. If x is negative, then the absolute value of the number is going to be the opposite of x. So, if we have a number line here, and we're going to do -3, -2, -1, 0, 1, 2, and 3. The absolute value of, for example, -3 is going to be how far are we from 0. So if we did hops, 1, 2, 3. We are 3 hops away from 0. The way we can see that is we just took the opposite of that sign. So it is the magnitude of the distance. It doesn't matter if we're to the left or to the right. It is just how far apart are we from 0, which is our arbitrary reference point. Now, +3, on the other hand, is 1, 2, 3 to the right. So the absolute value of both -3 and +3 is 3. It is the distance away. It's how many steps we would have to take to get to 0. And it doesn't matter in which direction we're looking. Now, we're going to get to our examples. Finding the absolute value of a number. When we look at letter A, we have the absolute value of 20. So this is the distance that 20 is on the number line away from 0, and it is just simply 20. It is 20 steps away from 0 on the number line. Letter C, we've got -9.5, and we're taking the absolute value. And if you didn't know, 2 vertical bars on either side of a number or an expression means we are taking the absolute value. So the absolute value of -9.5, well, that is going to be 9.5 steps away from 0. If we look at letters B and D, letter B, we have -11. So that means we are 11 steps away from 0 on a number line. And lastly, we have the absolute value of 2/3. We can even use absolute value with fractions. So the absolute value of 2/3 is just 2/3. Its decimal approximation would be 0.6 repeating. If you wanted to do that, I don't know why you would. No need to here. So our first, so we've got 3 U-try problems. You go ahead and do those on your own, and then we will go over them. Letter A is the absolute value of -23. So how far away is -23 from 0 on the number line? And that is simply 23, a very good number here in Chicago. Letter B, we have a 3 and 2/5. We have a mixed number. So what is that distance away from the number line? It is 3 and 2/5. If you really wanted to be fancy and make it a decimal, you could have said 3.4. That's up to you. But remember, fractions are our friends, so we are not just going to eliminate them because we don't like them. All right, absolute value of 3.14, the decimal approximation for pi, and that is simply going to be 3.14. 3.14. Now, we're going to go on to example 1, and we are going to write an absolute value expression. So letter A, we have the accuracy of a meat thermometer is the positive difference between the temperature reading on the thermometer T and the actual temperature of the meat M. What expressions are equivalent to the accuracy of the thermometer? Well, if we think about this, the accuracy of a meat thermometer is how close are we between the measured temperature and the actual temperature. And we want the positive. We want a positive value to that. So if we look at the absolute value of the temperature of the meat minus the reading on the thermometer, that's going to give us our difference between those two values. And it'll be So what about the absolute value of m minus the absolute value of t? We're going to get a negative number there. And so or we could get a negative number, or we could get a positive number. We just don't know what it would be. The absolute value of t minus m. Now on this one, we are going to flip this around, and we're taking the temperature measurement minus the actual temperature of the meat. And so by doing the absolute value of that, we are going to get a positive value no matter what. And on the fourth one, the absolute value of t minus the absolute value of m. So we're finding the absolute value of two things that are already going to be positive numbers because the meat's going to be above zero. It's not frozen, so it's going to be above 0 degrees when you are measuring it. So you're not really going to get a positive difference in this if, for example, your temperature probe is measuring cooler than what the meat is going to actually be at. So our two where the subtraction is happening inside of the absolute value bars are going to be our solutions or our answers. These are two possible ways where no matter what, when you do the subtraction, you then take the absolute value of it to get that positive difference. Now, we're going to go on to letter B. We have an amusement park, and a vendor is going to attempt to guess the person's weight. If they are not within 3 pounds, the person will win a prize. The person weighs 168 pounds, and the vendor guesses X pounds. What is an expression in which the number of pounds a winning guess is away from the actual weight? So let's look at this. If we are taking 3 and we're subtracting the person's weight, let's just say, for example, they said 170, and you do 3 minus 170, you're going to get negative 167. Does that really make any sense in this one? So that one's out. In the next one, we have, let's say again, if they guessed 170, 170 plus 3, does that tell us anything about how close they were in their guess? No, so it's out. We have 168 minus X, which is the person's guess. So if you did that, you did 168 minus X. That, if we were guessing again, if we said, for example, it was 170, that would be negative 2, and we take the absolute value of negative 2, and that's positive 2. So that would be within 3 pounds. So that certainly is one of our options. What about 3 minus 168? Does that tell us anything in relation to the guess that the person is making or the vendor is making? No, you're going to get negative 165, which really doesn't tell us anything. So that one's not it. So we only have one possible way of writing it out of the 4 that we were provided with today. Okay. Now we're going to move on to example 2, which is evaluating the absolute value of an algebraic expression. So before I said we could find the absolute value of a number, but we can also find the absolute value of expressions. So we have a whole bunch of things going on at the same time. We are going to substitute two values in and then take the absolute value of it. So let's start off by doing our substitution. We have negative 2 times x, which is 6, and we have negative 3 for y. Remember, I'm putting in my substitutions in parentheses, so it helps us remember what we've put in. It also helps us keep track of the fact that we are multiplying by negative 3, and we don't make a mistake and accidentally subtract it. So that's our first piece of this binomial. And now we're going to add to it 5, and we're multiplying 5 by negative 3 again. And so we close out our parentheses and we close out our absolute value bar. So now we need to actually simplify within. Absolute value bars do count as grouping symbols when it comes to order of operations. So we need to do everything on the inside first. Now when we look inside of this, we have two pieces of multiplication that we have to do first, and then we can do the addition in between. So we still have our absolute value bars. We're going to do negative 2 times 6 times negative 3. Well, negative 2 times 6 is negative 12. Negative 12 times negative 3 is positive 36, because a positive times a negative a negative times a negative will be positive. All right, so we have 36, and we're going to do plus 5 times negative 3 is going to be negative 15, because a positive times a negative is negative, and we have the absolute value bars. So now we combine like terms on the inside here. 36 plus negative 15 is going to give us a value of 21. And when we simplify that and we find the absolute value, we know that it is 21. Letter B. Hey, look, 23 is popping back up again. So we have 23 minus the absolute value of 3 plus 4 times x, and x is 2 for this one, and we have the absolute value. So again, we need to do what's inside of our absolute value bars first, and then we can work. So 23 minus absolute value 3 plus 4 times 2 is 8, and absolute value. We combine our like terms on the inside, so we have 23 minus 8 plus 3 is 11. So this is a weird time where we've got absolute value bars with an 11 around it, so it looks like just a bunch of lines up and down. The absolute value of positive 11 is 11, so we have 23 minus 11, which results in an answer of 12. Now, I want you to try letters C and D on your own, please, and then come back and check your answers against my work. Letter C. We are going to start by substituting in negative 4 for M, 1 for N, and 2 for P. So we have a negative, our N is 1, minus 2 times M is negative 4, and P is positive 2. So we have, in our first simplification, we have negative 1, and then we've got negative 2 times negative 4 times 2. So negative 2 times negative 4 is positive 8. Positive 8 times 2 is 16. So we have plus 16. And now we combine like terms. Negative 1 plus 16 is 15. We still have our absolute value bars. And so our answer is 15. Now, you might be asking yourself, Mr. Boland, why is it that you said that this was negative 2? Remember, subtraction can be the same as writing it as plus the opposite. So we could have plus negative 2 times negative 4 is positive 8 times 2 is 16. So that's where that came from. That's how I did that. All right. Next example, we have letter D, 4 minus 25 times the absolute value of 5 plus y, if y is equal to negative 3. So we have some stuff going on in front. So we have 4 minus 25 times 5 plus negative 3. So our first step is going to be to do that simplification on the inside. 4 minus 25 times 5 plus negative 3 is 2. We close the bars. So we take the absolute value of it. And remember, when things are, like, for example, right here, the 25 is touching the absolute value. It's touching the grouping symbol. So that means we are doing multiplication there. It is that shortcut. It is that lazy way of we're not showing the multiplication. We just imply it because they are next to each other like that with no other symbols. So we have 4 times 25, and we're going to have times 2. We need to do our multiplication now because that's order of operations. 4 minus 25 times 2 is 50, and 4 minus 50 is negative 46. That is the end of our notes for today and for Module 1. If you have any questions, please feel free to ask them in class tomorrow. Have a great day.